Everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at series and parallel circuits. Okay, so today we're going to be looking at series and parallel circuits, and we're going to be answering this question: what's the difference between series and parallel circuits? So have a look first here. Then I've got some different diagrams of some cells in series, and I've got a voltmeter that's recording the potential difference across the first cell there. It says it's 9 volts. What do you think will happen? What voltage, what potential difference will be across 2 cells in series and then 3 cells in series? What do you reckon? Okay, so one cell is 9 volts, but what happens when I add more cells in series? So let's grab another one. Both of these then are 9 volts, and when I put my voltmeter across, I get 18 volts. You can probably guess what's going to happen next. So that's 9 volts, that's 18 volts, 27 volts. So when you put cells in series with each other, we can add their potential differences together. Okay, so I'm sure you all guessed it. When you add cells in series, the potential difference across the combination equals the sum of the individual potential differences. Okay, so let's look at series circuits in a bit more detail. So circuit components are said to be connected in series if the same electric current passes through each of them in turn. So here we've got a series circuit, and you can see it's got 3 amps flowing out of the cell, 3 amps there still, 3 amps there still, 3 amps there, so all the way around the current is the same, 3 amps. The cell and the 2 lamps are in series with each other, and so the same electric current passes through all of them. But what happens to the electric current if we change the amount of lamps in this circuit? What happens if we add more lamps in? What happens to the amount of electric current? What happens to the resistance? Okay, so we've got a simulation from PhET here, and you can see I've made a little circuit with a cell, and we are measuring the voltage or the potential difference of that cell, and that's 9 volts. And I've got a resistor, and in series with that is an ammeter, and I've got a switch. So all of these things are in series. The little blue things here are the charges, the electrons, and when I switch the switch, you can see they move around, and the electric current goes up to 0.90 amps. Okay, so I'm going to add in another resistor to this circuit. Otherwise we're going a bit skew with. I'm going to turn the switch on. So now I've got 2 resistors in series with each other, and you can see that the current is now 0.45 amps. So the current is half as much as it was before. Now there are 2 resistors in series. Okay, so you can model a wire as a road that you walk along. So let's say that the road is wide enough for 2 people to walk side by side along it, and it takes them 5 seconds to walk down the road. Now if I make the road twice as long, and those 2 people walk at the same speed, then it will take them twice as long. It's twice as difficult for them to walk down that road. So it's the same kind of idea with a wire. It's twice as hard for the electric current to flow through the 2 resistors in series. So if I have one 5 ohm resistor, and then I add another one in series to it, then it'll be twice as difficult for the electric current to flow through. And if it's twice as difficult for the electric current to flow through, then the resistance is doubled. If I have 3 in series, then it's 3 times as difficult for the electric current to flow through, and so the resistance is 15 ohms. Okay, so that was series circuits. What about parallel circuits? So the total current through the whole circuit is the sum of the currents through the separate components. So here I've got 5 amps coming out of my battery, and then it hits this junction. If 3 amps go through the filament lamp, and there's 5 amps going into that junction, then that must mean that 2 amps go into the resistor, because 2 amps plus 3 amps equals 5 amps. Now 3 amps will flow through the filament lamp, and 2 amps will flow through the resistor, and so when they hit the next junction, they add back up again to 5 amps. Let's have a look at that in a simulation. Okay, so we've got a resistor in series with an ammeter, a switch, and a cell, and the voltmeter is measuring the voltage, the potential difference of the cell there. When I switch the switch, you can see we've got a current of 0.9 amps that flows through, and we can work out the resistance from that. Okay, so what happens to the electric current when I put a resistor in parallel with another resistor what happens to the current for the same potential difference. So let's see what happens. So now, by putting a resistor in parallel with another one, the current's gone up. So if the current's gone up, then the resistance has gone down. So when we add resistors in parallel to each other, then the equivalent resistance of them goes down. And by adding another resistor in parallel again, you can see that the electric current has gone up again for the same potential difference, and so the resistance, the equivalent resistance of these three resistors in parallel is less than the resistance of one of them by themselves. Okay, so let's have a look at what's actually going on then. So at the top I've got a thin wire. Now let's say that thin wire allows two charges to flow through it at any one time. The thicker wire will allow more charge to flow through it in the same time. So if more charge can flow through in the same time, then that means that the electric current will be higher. If the electric current is higher, then the resistance must be lower. So a thin wire has a higher resistance than a thicker wire because it lets less current through in the same amount of time. So let's have a look at that if I had two wires making up the same diameter as the thick wire. So I'd have two charges flowing through in the thin wire, and I could have four charges flowing through two wires in parallel to each other. So now I've got two wires in parallel to each other which are the same as a thick wire. Now we know that the thicker wire had a lower resistance than the thin wire, but if I've got two thin wires in parallel to each other, then it's the same as if we had one thicker wire of the same diameter as those two thin wires in parallel. So the equivalent resistance of components in parallel is less than the resistance of one of them by themselves. So if I've got a 5 ohm resistor, then obviously that would have a resistance of 5 ohms. If I put two of those resistors in parallel to each other, the combined resistance is less than one 5 ohm resistor on its own, and in fact it's 2.5 ohms. If I have three resistors in parallel to each other, the combined resistance is less again, and in fact it's 1.67 ohms. Okay, so this is what you should be able to do by the end of this lesson. You should be able to describe what happens when you add cells in series, and you should be able to state how current and voltage vary around series and parallel circuits. Okay, so I've been Mr. Baker, and that's been another physics video, and hopefully now you can describe the difference between series and parallel circuits. See you next time.